Hello and welcome to the first of some new videos, unfortunately being made here in the fall semester of 2020 for USN due to lockdown COVID-19 conditions. I may keep doing these. Students that I did them for in the spring liked having them, so it may be something that if I have time I continue doing all year long if I can, possibly just as sort of a flip video style introduction to topics and problem solving and things like that. So today we're going to be looking at a little bit of review in some ways, although I doubt you've done problems exactly like these, but really revolving around the idea of unit conversions. And we're really going to be getting used to the concept of manipulating numbers and units. That's a pretty important topic to get used to in AP Chem and in science in general. So we're going to be dealing with some units that you will not probably see again, maybe in your lives, but certainly not in chem. But getting familiarity with just how to manipulate them is going to be really the key concept. So we're going to look at two different kinds today. One which is very straightforward, and the other which kind of involves a little bit more in the way of manipulating some units that I think is good practice. So the more straightforward one is just going to be a process of simply using, I like to use factor labeling or dimensional analysis. If you are a proportion person, I would urge you to get out of that habit for these types of problems. It doesn't work. It unnecessarily complicates things. As soon as you have more than two units that you're comparing, the proportions don't really work very well. You have to sort of set up a whole bunch of different things and you tend to get caught up. So I would suggest that we do the method that we're about to pursue here. And if you're not familiar with this concept, what we're really using is simply a series of equivalences. And equivalents are things that we can think of as being equal for the scope of a particular problem. So you may not be thinking that 3 equals 1, for instance, like 3 does not equal 1. That is not an equivalence, but maybe $3 happens to equal 1 gallon of gas in America at this time. So that's an equivalence. $3 can be equal to lots of other things as well. A gallon can be equal to other things like 25 miles in your car or whatever. So those are different equivalences that we're going to use simply to convert numbers from one form to another, not changing the actual size of the number in terms of what it represents, but talking about it differently. Just like if I talk about a dozen bagels, I can talk about that as 12 bagels, or I can talk about that costing me $6 or whatever. So different ways of represent, or I can talk about it in terms of, it having, 3,000 calories or whatever. There's lots of different ways that we could talk about those kinds of things. So let's keep things kind of simple and start with a problem involving simply the price of gold, which as of this early August making of the video is $1,888 US per ounce. And let's say that we are international travelers whenever we're allowed to do that again, and we want to convert that into euros per gram. So we're going to kind of go full euro on this thing and try to figure out what that price of gold would be in units that make more sense across the pond, so to speak. So I don't expect that you're going to know a lot of these conversions. You should know some of them. You should know basic conversions like inches in a foot and seconds in a minute and that kind of thing. And you should also know your basic metric prefixes. So the centis, the millis, the kilos, that kind of thing. Later in the year, we'll probably get to know some of the other ones like micro and pico and things like that, and femto. But for now, we're just kind of keep it to fairly straightforward. So don't stress out about trying to learn all the strange and wonderful units that we may discuss, like poppy seeds, which, believe it or not, are a unit of length, and stones, which are a unit of mass, and things like that. So I'll provide those for you as needed. So for instance, 1 pound, you probably know, 16 ounces. You may not know that 1 pound is also equal to 453.6 grams. And there is also, as of this writing, a conversion that 1 euro is equal to $1.18. So what we're going to do is just kind of set up our conversion, $1,888 per ounce, and then just the factor labeling method, we're just going to kind of follow a series of factor labels that are going to convert this number, not in its actual size. It's still the same gold, it's still the same worth, the same value, just represented differently. Probably easiest in this case just to get rid of the dollars, because we just have one conversion to do that. You'll put the dollars on the bottom so that it will divide out And so we've got $1.18, and we have €1 up here. That will allow the dollars to divide out. We don't use the C word. Dr. Fitz and I are good friends, and we don't use the word that rhymes with schmenzel. So they divide out. That leaves us, you'll note, with euros per ounce. And we'll now convert ounces into grams. So the first one that we'll have to do that with would be 16 ounces per pound. That will get rid of ounces and now have euros per pound. And we have one more conversion that we could certainly say that in 1 pound, there are 453.6 grams. Now, if you're savvy and you want to combine these two by dropping the pounds and just putting 16 ounces over 453.6 grams, you can do that. That's fine. Just show your work along the way. And there's another video that you're supposed to be watching today about showing your work. That is immensely important for good science. It's also immensely important to get credit in this course. So when you do all that, you'll note everything divides out except for the euros and the grams, which is exactly what we want. That's a good way to track your work. And we get 56.4 euros per gram. I can't remember if the euros go in front of the number or not, but let's say that we're not sure. So I'll just sort of leave it vaguely in both places. It's good to have a little bit of a number sense. I don't know whether this will make sense or not. If you look at it and think, well, 56 euros per gram, is that good or not? Grams are obviously much smaller than ounces. There's 454 grams in a pound versus 16 ounces. And euros and dollars are worth about the same. So since they're worth about the same, but grams are much smaller, the price should not be 1,888 euros per gram. It should be substantially smaller, and it is. All right, on to our next topic, which is a little bit less straightforward. And that's what it's going to involve is sort of an internal conversion to make a factor label work with the problem that we have. So let's say we go back to the gasoline problem, and that instead of buying the premium at a nice easy $3 per gallon, you're going to buy more the 87 or 89 octane, something we'll talk about later in the year, $2.50 per gallon. And we want to convert that to the Ethiopian birr, abbreviated BR in our alphabet, per cubic foot. So how much in Ethiopian birr per cubic foot would that be? So I don't think that they sell gasoline by the cubic foot in Ethiopia, but let's just imagine we can manipulate numbers and find out if they did what it would cost. So some things that you probably need to know. As of, again, this making of the video, 1 Ethiopian birr is $0.028, so just a little under 3 cents. And some things that you may or may not know. 1 gallon is not too much different than, the liter is not too much different than a quart, 3.785 liters. One way to sort of think about that is that liters are larger than quarts. There's sort of a letter there, L being for liter and larger. So liters are slightly bigger than quarts. There's not 4 of them in a gallon, but close to 4. And then something that seemingly will not be all that helpful, but maybe down the line, there are 30.48 centimeters in a foot. And then there is, believe it or not, 1,000 centimeters in a liter. So we're going to use those to our advantage. So let's start with our given value again. Much like last time, we're going to have to write a little bit smaller this time. I think we've got one more conversion than the last time. So $2.50 per gallon. A couple of conversions here. Usually you can kind of look at the conversions I've given you. I'm not going to give you red herrings that you don't need to use. So we've got 1, 2, 3, 4 here. So let's go ahead and kind of plan to have 4 conversions. So the first one, let's go and get rid of dollars in favor of Ethiopian birrs. So 1 birr, 0.028. That will divide out the dollars. Now we've got Ethiopian birrs per gallon. Now we need to start getting rid of gallons. The first candidate is the liter, so gallon goes on the opposite part of the vinculum being the line that separates the two parts of our label or fraction, 3.785 liters. So gallons divide out. Now we have Ethiopian birrs per liter. The next thing we're going to do is go ahead and get to centimeters cubed. So 1 liter, 1,000 centimeters cubed. And just as an aside, if you don't know, the cubic centimeter is also the exact same thing as a milliliter. So 1 cubic centimeter is the same thing as 1 milliliter. So both measures of volume that are equal to one another. Now, we get to the tricky point here, which is this whole centimeters to foot thing. So one way to think about this is what we're looking for is centimeters cubed. And the unfortunate thing that some students do is they simply write 30.48 centimeters, and then they just decide to cube it. And that's, of course, not really how cubes work. 30.48 centimeters is a length. It is a line. It is not a measure of volume. And so if I have 30.48 centimeters as length, and then I have 30.48 centimeters as a width or a height or whatever, and then I have 30.48 in another direction like this, and I end up building a cube out of those 30.48 centimeters, then I have 30.48 centimeters cubed in a sense, because what I really have is a foot by a foot by a foot. And so I have basically a box that is 1 foot on each side, so a box that is a cubic foot. And what that means is there's way more than 30.48 cubic centimeters in that box. I mean, each cubic centimeter is tiny, right? There's 30 of them that go across any part of this cube in all directions. So we've got 30, at every one of these faces and all through in between the faces into the interior. So there's a whole bunch of cubic centimeters in a cubic foot. If you think about, I guess it depends on the size of your screen. If you're looking on your phone, it's not. I'm drawing on my iPad. On my iPad, this is a relatively life-size cubic centimeter. It's probably a little bit big. So that's a cubic centimeter. And so a cubic centimeter, if I think about a cubic foot, I mean, a cubic foot is 12 inches or 30.48 centimeters, in all sides. Like you can fit a whole bunch of these little things in there. So it's 30.48 quantity cubed, 30.48 times 30.48 times 30.48. And technically it's also 1 foot times 1 foot times 1 foot, which is 1 foot cubed. And you can, of course, get away with writing that as 1 foot cubed without the parentheses, because 1 cubed is still 1. So that will allow the centimeters cubed to divide out, but don't forget that you still have to take care of the 30.48 being cubed. When you do that, you get, if I do the math correctly, which I don't know if I will, we'll have to maybe check later on, around 668 Ethiopian birr per cubic centimeter. That seems a little high to me, but that cubic centimeter number is rather large, and so it could certainly produce such a large number. It seems like a lot of money to pay for a tiny amount of gasoline, a milliliter of gasoline, but the birr is not worth a whole lot compared to the dollar, and so certainly since it, 1 birr is about 3 cents, it's going to be 750 birrs or so to the gallon, and if it's about that much per gallon, no, that's not right, is it? 30? No, it's about 75 or 80 birrs per gallon. And so if you think about how big a cubic foot must be, I don't know why I wrote cubic centimeters there. A cubic foot must be pretty darn big. And a cubic foot is actually a pretty large amount of volume, certainly compared to a gallon. If you think about a gallon of milk, it's not a foot in all directions. It may be close to a foot tall, but it's certainly not a foot in the other dimensions, and so you can have certainly quite a bit of volume out of a cubic foot. So that's the one sort of tricky thing you'll encounter in some of these unit conversions, is dealing with volumes or squares, if you're dealing with areas. So just kind of watch out for that. Make sure that you not only square or cube the unit, but also the associated conversion number with that. So square or cube the unit as well as the number. So the 30.48 in this case got cubed, as did the 1. Just cubing the 1 doesn't matter a whole lot. All right, hopefully we'll see you soon.